Today I'm going to show you two different methods how to calculate simple interest. First, I'm going to show you how to use the standard interest formula to calculate the answer manually. Then I'm going to introduce you to the future value interest factor table, which will provide you with a simplified means of finding the same answer. The standard interest formula allows you to calculate the answer manually. Our problem has us putting $10,000 into a bank account for 3 years, earning 7% interest annually. Okay, let's go ahead and identify the components of the formula, starting with FV, that's the future value in the number of periods. That's what you're trying to figure out. That's how much money you're going to have in 3 years. Next, you have present value, which is just that, the $10,000 that you're putting in the bank. You can find that right in the problem. How about lowercase r? That represents the interest rate. Again, that's also included in the problem, as well as lowercase n representing the number of time periods, which in this case is 3 years. However, let me let you know, it's not necessarily always years. It could be representing quarters or whatever, depending on the problem. Now let's plug our numbers into the formula. Okay, starting with the $10,000, the present value, plug it right in there. Next, we're going to have the 7% interest, which you'll see I actually convert that to 0.07 so that we can actually multiply it. Okay, next, you're going to see 3 years. And that's an exponent. You're not going to just multiply that by 3. You're going to actually cube that answer. And I'll show you that here in a second. So let's go ahead and figure this out. But we have to remember the mathematical order of operations dictates this is how you have to solve this in a particular order. Add the figures within the parentheses. 1 plus 0.07 is 1.07. Next, you're going to calculate that figure by the exponent, 3. 1.07 times 1.07 times 1.07 is 1.225, which then you're going to multiply by the present value. 10,000 times that is $12,250. For future reference, you can use the acronym PEMDAS to help you remember the order. It stands for parentheses, then exponents, multiplication, division, addition, subtraction, in that order. You can also expand it to the mnemonic, please excuse my dear Aunt Sally. How clever. Okay, now I'm going to solve the exact same problem using a different method. This time we're going to skip some of the math that was involved in the last method by using the future value interest factor table. Now, as you can see, many of the same components are included in both formulas. For instance, the FV and the PV are the same as both future value and present value. You also have the FVIF. Now, that refers to the table we're going to be using, Table 1. Make sure you make note of that because I actually use 4 tables. I'll get to that in just a second. Now, the lowercase r and the lowercase n immediately following the FVIF represent the interest rate and the number of periods, respectively. Okay, let's go ahead and populate the formula with the values from the problem. We're going to start out with that $10,000, so let's go ahead and add that in the formula. Boom, there it is. And the interest rate is 7%, so let's go ahead and add that. Okay, there we go. And the number of periods is 3 years, so let's go ahead and add that as well. Now notice the lowercase numbers shown in the parentheses, the interest and the number of periods, are merely actually there to reference the formula. And I'm going to show you that here in a second when we go to the FVIF table. They're not going to be actually used in any kind of a mathematical calculation as they were in the previous method. So a lot of times people don't understand that. Okay, here's Table 1, the Future Value Interest Factor Table, or also referred to as FVIF. You can see on the top line you've got the interest rate, and along the left-hand margin you have the number of periods. Again, keep in mind, number of periods doesn't necessarily refer to years. Okay, I've included the formula, our formula for our program at the top center. The interest rate is 7%, and the number of periods is 3. So I've referenced that in the small box up at the top right. Now you see I've actually highlighted the 7% interest rate on the top line. That's, I derived that from that formula. So you can see that's where we're going to start there. On the left-hand side, we've got the number of periods, 3. I put that in blue. And then you can follow along both of those to the purple box. That's the factor we're going to actually use in our formula, that 1.225. You can round it off. So that's what we want to take away from using this, this table. So basically, we insert that into the formula. FV equals 10,000 times this factor, which is 1.225. Add that to the formula. Bingo, bango, there you go. And then if you multiply that, 10,000 times 1.225, you get 12,250. So that method estimates that you're going to have $12,250 in the bank after 3 years in that interest-bearing account. And if you'll recall, that's the same as the other method. So they both yielded the same answer.